How are you guys? Welcome back to my YouTube channel. We still continue with mathematics N4. This is question 4. Alright, says we are given for question 4.1, given f of x that, you see this is cubic, is equals to x cubed minus 2x minus 4. Say using differentiation, calculate the coordinates of the turning points and the point of inflection. Also distinguish between maximum and the minimum turning point by using what? Second derivative. Alright, this is 10 marks there, as you can see. Alright, we want to find what? Let us start by finding the turning point. Obviously, we know when you're given the derivative, here it's a turning point there. We want the turning points. Alright, so that is what we want there. So we've given 4.1, we've given f of x, it's equals to x cubed minus 2x minus 4. We know that at a turning point, it's when the first derivative is equals to what? When the first derivative is equals to 0. So it's we're at a turning point. So we can take f of prime first derivative there. If you take the first derivative, you drop the exponent, you'll have 3x u minus 1, there will be squared minus 2, right? Obviously, f of x must be equals to what? To 0. We have 3x squared minus 2. Alright, so I can just take 3 to the other side. I'll have negative 3x squared is equals to negative 2. Then I will divide by negative 3 both sides. Alright, so this and that will figure we'll have x squared is equal, that and that will cancel, we'll have 2 over 3. Then I'll take the square root both sides. But when you take the square root, remember we have, I'm taking square root, I will write here. Remember, when you take the square root, you have plus or minus. So I will have plus or minus square root of 2 over 3. That means, since we have 2, therefore that means we have x is equals to positive. We have the positive 1, 2 over 3. Also we have x equals to negative square root of 2 over 3. Those are values of what? Of x weight cut. So let us find the y values. So remember, one the coordinates, not the x values. So I can say if we've given, if our x is equal to this guy there, if our x is equals to square root if our x is equals to the square root of this, we know we want y. What will be the y value there? What will be y? So we substitute on the original equation there, the one x cubed minus 2x. So we have x cubed minus 2x minus 4. That is our original. So we want y value. We'll substitute there. The square root of 2 over 3 cubed minus 2 square root of 2 over 3 minus 4. Then what will be the y coordinates there? We'll have a negative y coordinates there. Will be minus 5, 089. This is our coordinate that will obtain there, our y coordinate, our y point there. So we know, so that it's a turning point 1. I can call this turning point 1. We have used this x value. We'll have square root of 2 over 3 positive, and another coordinate, y coordinate, will be negative 5,089. So we have that one. Let us check this one now using the negative. if we'll have the negative coordinate, we will want to what? Y. So let us have our y again. So y using the negative will be negative root 2 over 3 cubed minus 2 negative root 2 3 minus 4. So then what will be y here? Y now, when we are using the negative 1, we'll have that to be negative 2 comma have negative 2 comma 91. That is a y coordinate. That means turning point 2. You can call this turning point 2. Our value here, we have negative square root of 2 over 3, and y coordinate will be 9 minus 2 comma 91. So we have these two turning points here, coordinates of the turning points. All right, so we did that, but they said we should also what? Determine what? The point of inflection. The point of inflection, we know is supposed to take the first derivative. The point of inflection, we must take the second derivative. All right, so f prime, we know prime of x already. We had prime of x, our prime f of prime we already had there. Here it is negative. Wait, negative, let me just grab this. We've already had prime of x, so that was the first derivative. Let us find the second derivative. I'll take f prime of x. It will be 6 there, then subtract 1, this will be 0. So this is what, or someone can use dy over dx, then the second derivative will be dy squared over dx squared. It's one and the same thing, so I can use f of prime or f of prime x. It's a one and the same thing. The notation is the same. All right, that is what we have here. So we know at a turning point, it's when the second derivative is equals to 0. So we'll have 0 here, 6x, isn't it? We took error there. We have that. So we'll divide by 6 both sides. If we divide by 6, we'll have x value will be simply equals to 0. So we'll substitute this 0 into our original equation. Here it's our original equation. We'll substitute our 0 to find the y value. To our original equation, we have 0 cubed minus 2, 0 minus 4. So we'll have minus 4. So the point of inflection, there we'll have this. X is what? Is 0, and y there will have minus 4. So this is the coordinates that we had. So remember, they said we should also determine maximum and minimum turning point. We must tell between these two turning points. All right, we have two turning points. We must tell between turning point 1, we had the square root of 2 over 3. Then we must tell which one is we have this 2 over 3 and negative 5,089, and the turning point 2 square root of 2 over 3, negative 2,91. So which one is a maximum and the minimum? We want to extinguish which one is the minimum and the maximum between the two. How can we get that? They said extinguish the maximum, extinguish the minimum and the maximum turning point. Please tell us which one is the maximum and the minimum. How can you tell? Because we've just calculated, we don't know. We want to know which one is the maximum and the minimum point. Okay, to tell that we'll use the, if okay, you tell that you use the second derivative. If your second derivative there, if you obtain a positive value, we are using yours. If you have obtained the positive value, then that will be a minimum point. How we took it, we'll have a minimum point. If you have obtained the negative value, then we will have what, your maximum point. You'll have minimum point. If your second derivative will obtain negative, will be negative value, this will be our maximum. All right, let's check. All right, we know the first derivative we had, the second derivative is here. Our second derivative is what? There is equal to 6x. So between these two coordinates, we have to this and that, right? Between these two coordinates there, we took it. So we substitute the x value. Let's start by turning point 1. Let us test which one, this turning point 1. So substitute the x coordinate there, will be 6 into 2 square root of 2, 3. Then we punch this. We're supposed to see what are we going to get. You'll have 4 comma, our second derivative there will be 4,89, right? So this is what is a positive value. That means TP, turning point 1, it's what, it's a minimum, will be what, the minimum one, because you've obtained the positive. We said when you obtain the positive, you'll have that. We have discussed about that, isn't it? So we have now the this will be minimum, turning point 1, because we've obtained our second derivative as positive. So TP, turning point 2, obviously we will use your second derivative, and to evaluate it, our second derivative we have there 6x. So let us substitute that. We'll have negative square root of 2 over 3. So this will give us what, minus 4,89. So this guy will be what, the maximum one. We took it, we'll obtain the maximum. This will be the maximum turning point. All right, that is how you go about. So this T1 will be maximum, T2 will be minimum. So this is how you can go about. All right, so we've given 4.2. Then 4.2, we've given that y is equal to square root, of course, of cot x. Take the derivation using what, the chain rule, function of function. Check, you must use a formula because they say function of function. If you have forgotten the formula, you may quickly go to your formula sheet. Here it's a formula sheet, do not forget. If you have forgotten, you can simply take the formula sheet. On your formula sheet, you will see you'll have here it's your, this is a chain rule there. As you can see there, you've given dy over dx must be equals to dy over du multiplied by du over dx. Function of what? Function. All right. That is what we'll have there. Are we together? So, must note. All right. We have seen that what is that we know, but we have given 4.2 is equals to what? Our 4.2, our y must be equals to the square root of cot x there. That is what cot x. All right. So we've seen that function chain rule is equals to dy over dx must be equals to dy over du multiplied by du over dx. This is a functional function that we're supposed to use. All right, let me just rewrite this. Is the same as you know, most they say the same as what this thing there, same as cot brackets there, cot with cot x, that one, this guy, it's the same as what, remember, the same as cot x into 1 over 2. You remember most the sets, the laws there. That is what you can rewrite this in this format. That is our what, our y. You have not changed anything there. So you can let u to be equal there inside. Let u to be equal, let u to be equal to cot x, right? Then since we have what here, du over dx, take that du over dx. All right, then we'll have du, we must have du over dx. So when you differentiate, cot will be negative cosecant squared x. This is on your formula sheet if you've forgotten this. Now we have this guy already. We've determined this here. So let us go and find this now. Let us find dy over dx over du. We want that. All right, so since we have said, remember we have let this to be equals to u, so we'll simply have y is equals to u raised to the power of what, of 1 over 2. Remember that is equals to u. So we'll have now dy over du. You drop the exponents, will be 1 over 2. You subtract 1, they will have negative 1 over 2. So then we have that. This is the same as, u will be the same as 1 over root square root of u, like this. Remember this guy. I understand, because we have 1 over 2. If u minus 1 over 2, you can rewrite this, it will be the same as square root here, square root of what, of u. Remember here we still have what, over 1, like that. We have just taken that, because why we have this is because this is the same as, if you take that to the exponents, u will be 1 over 2 on the denominator if you take this to the bottom. But this guy, you know, u 1 over 2 will be equals to what, the square root of 2. So we'll obtain 1 over root 2. So I'm taking root u. Example, I want to say that u. So that is how you obtain that. So, but the u, I want you to not forget there. But the u, what is u? U is what? From the original, we said let u to be equals to what? To cot here. So we can replace here with what? With cot. So we'll replace that with what? With cot. So we still have dy over du, but now du or dy over du will be equals to what? 1 over, we have our 2 there. This u is the same as what? As cot x. So that is what we have there. Now we can multiply, because when we check here we have the multiplication, so you can multiply du and dy. So we can multiply there. We want dy over dx. Remember, it's equals to what? As you can see, it's equal to du dy over du. What way is dy over du? Is this guy, is this, so it's same, it's 1 over 2 cot x multiply by what? By du over dx. Here is du over dx. It's what? Multiply by negative cosecant squared x. So it's a matter of mathematics now. Dy over dx will be equals to what? You multiply here. So multiplying, this will go to the bottom. We'll have negative cosec squared x divided by 2 square root of cot x. This is what we will have now there. All right, that is what we will have there. Sorry about that. So that is what you have. That is what we'll have. So we have now 4.3. 4.3 says determine that you've given that x to differentiate in terms of what? Of x there. All right. I can clean here. All right, what we should differentiate there. Check the differentiate with respective to what? To y. Okay, we have x is equals to, let us rewrite this, 1 over, we have 1 over like this, 1 over like this. So let us rewrite this in the nice format. This is the same as what? Same as 1 y 1 over y raised to the power of 1 over 3. We know we can take this to the top. If we take that to the top, this will be y minus 1 over 3. We've simplified the first one. So the second one, we have minus 1 over cosec 2y. All right, that is what we have there. So what about that? That is what we have there. We took it. So this obviously cosec is the same as what? Remember, this is an inverse. It's the same as 1 over cos will be 2y. So remember, we still have what? This 1 on the top over 1 like this. So this will simply equals to what? This will be equals to cos 2y. Alright, this will simply equals to that. So we'll have cos 2y plus ln of y. This is good. We have again minus, this one does not we have minus e minus 2y over 4. This is good. Plus I can rewrite this as the same as what? As 1 over 4 e minus 2y plus this guy is the same as 5 over 2. Alright, same as 5, same as no. There I have 5 over right. This is the same as 1 over 2 multiplied by what? 5 over 3 pi y minus that p pi 0 plus 6 pi y. Alright, let us differentiate this in respective to what? To y, guys. Alright, so in respective to what? To x, to y. So we'll have dx with respective to y. We have y's here. So here we're supposed to write y with respective to that. So you drop the exponents, would be minus 1 over 3 y, you minus 1 again there. We are differentiating, isn't it? Negative 1 over 3 minus 1. What will be? Will be minus 4 over 3. So you come to this one, you have a negative. You differentiate what? Cos. When you differentiate cos will be what? Negative sign, but you already have what? You already have a negative. So now will be positive sine 2y. But do not forget to multiply by what? By the angle, the inside, the derivative of the inside angle there. Multiply by what? By 2. Alright, or you can write like this. Will be multiplied by 2 sine 2y. Chain rule. The chain rule there. Plus ln y same as what? Is 1 over y. Together minus. So we have 1 over 4. Then here you'll write that as it is. Will be e minus 2y. Will never change. This will be like that anyway. We together multiply by the derivative, chain rule there. Multiply by the derivative there. Okay, derivative of this multiply by the derivative of this will be multiplied by negative 2, then e minus 2y. That is what we have there. Let me reduce this a bit. So we have there is negative 2y. Now we go to this. We have plus 1 over 2 multiply by the derivative of this. Obviously we have pi, we'll multiply this by what? By pi. And multiplied by pi. We have multiplied by 5, 3 pi y. Anyways, this is the same as what? S1, like will be 0 minus 0 plus. Take note, here we're supposed to apply the product rule. Let us try and apply the product rule here. We have 6 py. We have to apply what? The product rule. if you have for cotton is there on your formula sheet. Product rule says if you have f of x multiplied by g of x, example, the derivative of this must be equal to f of prime multiplied by g of x plus f of x multiplied by g of prime. So I can let p to be equal to f of x and let y to be equals to g of x. So that is what we'll have there. Obviously we have our 6 outside, so let us not forget about this 6. Let me just multiply this by this 6. It's just a coefficient there. All right, which we have this. I can multiply by, it's okay, we'll multiply by that at the end. Let me just write here our 6. Anyway, multiply this by 6, whereby it's a coefficient, isn't it? So let us start by differentiating. Prime of x, I said it's what will be p. So derivative of that, but remember there we said to differentiate with respect to what? To y, isn't it? So this will be what? And simply equals to 0 anyway. With respect to that, this will have here 0 multiplied by y, this is y, plus the derivative of that plus this f of x is what? Is p. The derivative of g is y, will simply be what? 1. Alright, so this is what we'll have there. So this will be what? We still have 6 all over actually like that. This will be what? Will be 0 plus this will be p. So this will be 6p actually. We'll have 6p, applying what? The product rule there. So you must show that will be what? Plus 6p plus 6p. So this is what you'll have there. You have applied the product rule. Are you good to go? So we have that. We are done with that. So 4.4 say y is equal to cot. Use what? Quotient rule. Y is equal to cot. We're supposed to use our quotient rule. Y is equals to cot x. Use a quotient rule. If you have forgotten, it's there on your formula sheet. Let me show you. Let me show you. Here is your formula sheet. I want to show you your quotient rule. Here it is. There. There is the formula sheet. Here it's of quotient rule. There it says dy over dx must be equals to what? You say v of x multiplied by u prime of x minus there u of x multiplied by v prime of x. Divide this by what? By v of x what squared. Alright, so let us relate this. Let us use y. Let us not use this v. How can this thing is the same as dy over dx is equals to f of x multiplied by g of prime x minus f of minus g of prime, same as like that, of x multiplied by f of prime x, divide this by what? Now divide this by what? By f of prime squared. So this is one and the same thing. You must understand how to use this quotient, but let you use this the one that which is in your formula sheet. So we have v and u, right? So I will let so remember y, remember cot, it's the same as what is cosine x divided by sine x. So we have two things there. This is a fraction anyway, so I can let cos, we took it, I will let v of x to be equals to what? We'll just let it to be equals to sine. Are we together? Then so yeah, is what you edit anyway. This is what you will have, like v of x over u of x. So I can let well, in the end it's up to you guys. Let me just let cos is the one. Which one do you prefer? Is up to you there. All right, all you must know is this thing there at the end, this one. All right, let v of x to be equals to sine, anyways, to be equals to cos. Okay, then I can let it to be equal to cos x. Then I can let u of x to be equals to sine x. But as you can check here, we have u prime with v prime. Let me find v prime of x. What will be v prime? Will be negative. Remember, this is cos. Right? Will be negative sine x. Then u prime will be what? Will be positive cos x. So we have this. Now we can substitute on that, on this formula there. We can have our dy over dx, using the formula. We have what? V. The v is cos. We'll have cos x multiplied by u prime. Here it's our u prime is cos again here, multiplied by cos x. We have minus here u prime, u. Now this is u. Okay, u of x is simply what? Sine x anyway. Are we together? Then multiply by this again. V prime is here, which is minus multiplied by which is what? Is multiplied by negative sine of x. All right, divide this by, remember, we square the bottom part. Are we to get v with v there? We square v. All right, we're supposed to square that. The bottom part must be squared anyways, so must check what we'll have there on the top there. We must square. Remember, when you take the derivative of this directly, what you're supposed to have there supposed to have negative cosec squared. Negative cosec squared, whereby without using a quotient rule, this must be negative cosec squared x, whereby this is the same as what? You can also use 3, which way this is the same as 1 over sine squared x. So so must be where at the bottom there you square what? Sine. So here we'll have sine, I will square this sine there. At the bottom I'll have sine x, then I square that. So as I square this, they have dy over dx. This will be cos squared x. Negative and negative will be positive sine squared x all over sine, drop putting that squared x. So dy over dx, this is the same as what? This 1. Remember, will be 1 from your trigonometric identity, sine squared x. Alright. So we're supposed to have a negative. Where is the negative? When I differentiate this here, alright, if v cos u will be positive, alright, like that. This would be dy over dx, be cosecant squared x, but supposed to have a negative here. Let me check where I did it. The mistake there, somewhere there. Okay, I differentiated this, must be negative, which is good. Then I differentiated sun must be positive. Alright, what is the mistake here? We were by okay. Oh, okay, I must use positive there, negative. Okay, I see. When I have there on the top, I supposed to have, I will left it a negative there on the top there, whereby this will result to have negative cosec squared x there, because we have x. This is what we're supposed to have there.